A question to Sabine regarding the residential VPP. My question is there a business model behind your residential VPP? Could you lose a few sentences about that? Would be great. Thanks.
So we are a B2B2C company. So our customers are actually the energy provider. And then we install at the place of their customers our devices. So the business model is that we help the distribution provider, energy distributors to do, for example, peak shaving. So they can, play with load balancing. And then we offer to their customer the possibility to have this smart home, which is also something attractive for customers.
Hi, my name is John. I'm also have a question for Sabine. You mentioned that some of your software is designed for maximizing self-consumption, and you use it for shifting loading time. My question is sort of how do you actually execute that?
So I'm not really an expert of this particular algorithm, but what we do is really analyze. For example, at what time and how much hot water a customer will be boiling, and just shifting this load in time, but taking into account, for example, the weather conditions, so the radiation and so on.
So my question is also to Sabine. I personally come from a home appliance company, so for me it's quite interesting to know how you enable your turning on or off your the home appliances in the household from the grid. Yeah.
We develop our own hardware. So we have switches that we install directly on home appliances which are already installed. So someone can have a very old electrical heater. We will change the cabling in order to add a switch that we can control. And then we have a gateway which communicates with us and transfers the data. And in certain cases, we also add sensors so that we can have a feedback loop on the temperature inside the house.
So it's like an add-on something on top
Yes.
of the appliances?
Yes.
Okay, so it doesn't matter whether this appliance is a smart appliances or it's just a normal one?
For the moment, we work mainly with normal ones, but we can, of course, take into account that there will be more and more smart appliances and work with also the APIs already provided by others.
Okay, thank you very much.
May I also ask a question?
Yeah. Olga, maybe first.
That's okay. I actually had a question to Emanuele. You're a PhD student yourself, so you're kind of part of the system that is not publishing the applied results. Are you publishing your results, or what are your measures to overcome that?
So, let's say it's not so easy. I had to fight with legal departments of companies to get through it. We won one time, we lost twice. So finally they won. That's the problem. But basically, the two papers you can find in the references are based on an algorithm which is now in production in one of the biggest energy providers in Italy. So it is possible. Of course, it requires a lot of commitment, both by companies, which should be able to realize that, hiding everything is not the solution, and by the editors, which should understand that even if it's not something completely new, if it is something that works and combines different pieces together, maybe it's worth publishing.
But what was your experience also with the publisher?
With the publisher, it was quite good, actually. I think we got rejected once, but it was right because the paper was very bad. I was the first author, but I'll tell you, it was very bad. It is much harder with companies because they say, come on, I paid you to do this work, and now you want to publish everything? It's not fair. Well, in my opinion, it is, but I'm the minority. Thank you.
I have a question for Olga. You mentioned the possibility to transfer the knowledge that you acquire for monitoring one kind of asset to a new OEM, for example. Could you spend a few words how you did this or how you plan to do this?
So you mean if we have different manufacturers,
yeah,
or
for example,
if we
you
have
mentioned
one manufacturer? So
different manufacturers. For example, you made the example of a gas turbine, right? It could be done by Siemens or whoever else.
This one was actually from the point of view of one manufacturer. So it was a fleet of 100 gas turbines of the same manufacturer.
Indeed. Mm-hmm.
So it was not quite the same set of sensors that we were dealing with. So, this was we selected the most similar model. So this was the very first step that we did. And the second step that we did, we applied domain adaptation to adjust the operational experience to the one of the specific gas turbine. And this was actually working really nicely. What we didn't do and what we are planning to do now is to extend this to the case where we have different manufacturers. But this is actually a bit more difficult task, and this is also where we hope to apply the hybrid approaches, because there we try it can be then a bit more sync or a bit more standardized or generalized at the physical model level, and then we can connect different type of sensors and still use the physical process models. But that's kind of the future work, and the current work is just from the point of view of the same manufacturer.
Thank you.
Cool, thanks a lot. Are there any urgent questions? Okay.
I have a question for Emanuele Fabiani, because one of the initial remarks was this, that there is no data, current data available for energy consumption. And as a normal person, I'm just aware of the European Energy Exchange, which has transparency data available for the actors in the financial markets, but has the consumption of and the production of all sorts of power plants in Europe, Germany, Hungary, Austria. And I wonder if you're using this for your research.
Okay, this is a very good question. The answer is no, we are not using them because, okay, this was related to a real project where we had to forecast the regional power load in Italy. Basically, the rules of the games are like this. Every energy provider in the country, in Italy, has to provide day-ahead forecasts of the consumption for its own customers, and it has to do it on a regional basis, divided by, let's say, industrial customers and residential customers. So if we just look at the production data, this would not be enough, because they would be basically aggregated. You have no idea to separate if a megawatt produced by a certain power plant goes to a residential customer or to an industrial customer. And the problem is that the only authority which has those data, which is the transmission system operator, gives them to the companies with 2-month delay. I'm not aware of a good explanation why this happens. They told me it is because they have to estimate lots of this data, let's say calculating differences between production and transmission. But basically, there is no way around this problem, as far as I'm aware, and as far as our customers were aware. Thank you.
Cool. So thank you very much. Then there are 2 things left. First of all, I would like to thank all the speakers. And of course, we are here in Switzerland, so we're very happy to present them a box of chocolate. I'll just try to pause. In the meantime, as you see, we have poster pitches. So I would like to ask the 3 contributors of posters to come forward and present themselves for a short pitch, which will start as soon as the chocolate is distributed, of course. So,
thank you so much. I had 1 minute. Okay, what is recurrence quantification analysis? We have the power system. We measure one signal. With the signal, we build the phase space. With the phase space, 2 points in the phase space are recurrence is the distance between them. are smaller than the threshold epsilon. Sorry, one equation. And then we build the recurrence plot, and the recurrence plot is the fingerprint of the original event in the power system. And the patterns in the recurrence plot say something about the dynamic in the power system. To measure the patterns in the recurrence plot, we can use metrics belong RQA, and we can use also these metrics to build one score plot and visualize the cluster of the signal. Why use recurrence quantification analysis? Because it's a technique not restricted. We can analyze a linear and nonlinear system, a high robustness to noise, and the mathematical simplicity. Thank you so much.
Please keep in mind, the posters are currently mounted at the poster area. If you walk down this aisle to the left, so very close, on your way to the coffee, you will visit this respective poster. So please have a look. And of course, our colleagues will be there to defend their work. Next one is Xiufeng Liu. Hopefully that's not completely wrongly pronounced.
He's not here, but maybe I can say a few words. I think he's attending another session. I'm Peter Sivertsen, I'm the last over here. So obviously I've got all my fingers done in the work. But what we're trying to do here is try to visualize the electricity flow in a district. So by using visualization, data to visualize where the congestion in the network is. So we can, for instance, see how the electricity is flowing from the industrial area to the residential area during the afternoon. So by 5 o'clock, you can see how the electricity is going into the residential sector to make food. So this is what the main idea of this data analysis has been.
Great.
You can see the details out there.
Great. And eventually, what are you going to do?
Thank you. Good afternoon. So I would like to present to you our reinforcement learning approach towards the energy efficient electrical vehicle routing problem. And in particular, why is that important? Because the amount of electrical vehicles that we see currently on the road is growing, and they represent an important source of flexibility for the energy systems. And if we would be able to know throughout the day where these cars are moving, then eventually we would be able to help to solve energy challenges, such as, for example, the increase of the self-consumption. So what we are trying to do here is, by using the temporal difference with Q-learning, is actually to provide the optimal trajectory for the electrical vehicle to move. So we operate here in the graph setting. So our agent is moving from some starting point towards the destination. And this algorithm is incorporating two important features of solving this problem in the domain of the electrical vehicle. So the first one is that the opportunity to recharge on the way. And the second one is the ability to actually recuperate the energy while moving. This problem we formulate as a Markov decision process, which has a particular set of states and actions. And once the agent is moving or performing particular actions, it's receiving the rewards consecutively. And in this regard, we have as well applied this algorithm to a live case study, which actually is a region in Switzerland in Val d'Airain. And I would welcome all of you to learn more about this work in the poster presentations later. Thank you so much.
Great, so thank you very much. Just a reminder, poster session at the end of this aisle to the left. And then the third thing to remind you is there is a coffee break served outside. Please be back at 3:30 for the next session. Thank you very much.